Good day viewers, you are welcome. How to solve these nice exponential equations? Let's see a solution from here. So we are given a to the power a equals 10. So if I write the question as a power a equals 10. Then from here, let's introduce logarithm on both sides. So I'm going to introduce natural log on both sides as we have ln a raised to power a equals ln 10. Then from here, let's say we apply the rule of log. We take this a down and we have a multiplied by ln a. So this equals ln 10. And into here, let's try to rewrite this ln as we have ln multiplied by. So if I write this as multiplied by a, so both are still the same. So just like I reposition it, and this equals ln 10. So we have to understand a particular concept here. So if this is a, we can write this a as, suppose we have ln a multiplied by this a, if I write it as e raised to power of ln a, this equals ln 10. Because e and ln, they inverse to each other, so they cancel. So I just use it to manipulate this. So there is a particular concept I want us to understand here, so which is Lambert W functions. So it says that suppose we have the omega of a e raised to power a, so this equals a. So we have to understand this. So when this and this are the same, the coefficient and the power of this exponent are the same, so we are going to choose only a. And that is what we are going to apply here, because ln a and this power of this exponent, they are the same. Then we can now introduce this function, which is Lambert omega function here, and we have the omega of ln a multiplied by e raised to power of ln a equals the omega of ln 10. So we have something here, and we have already shown that we are taking only ln a. So when we take ln a, so this equals omega of ln 10. And the question says find a, not ln a. So the best thing we can do to take this one out is by introducing exponential to both sides. So here we have e raised to power ln a equals e to the power of omega of ln 10. And this cancelled. So when they cancelled, we have our a equals e to the power of omega of ln 10. And here is the result to this problem. Thanks for watching, and if you are new here, do well to subscribe and turn on the notification bell. See you in the next class. Never stop learning. Bye bye.